Have you ever thought about how your devices connect to each other or even to the internet? From your smartwatch syncing with your phone to global communication across continents, different types of networks make it all possible. Welcome to WhiteboardDoodles, the channel where we simplify tech-related concepts using whiteboard animations. Today, we're diving into the world of networks, exploring the different types, how they work, and where you might encounter them in everyday life. Let's get started. A computer network is a system that connects two or more devices, such as computers, smartphones, or printers to share data, resources, or services. These connections can be wired, using cables, or wireless, relying on technologies like Wi-Fi or Bluetooth. Networks enable communication and collaboration, from sending an email to streaming videos or accessing shared files on a server. Depending on their size and purpose, networks can range from small personal setups to vast systems like the internet. Now let's explore the various types of networks you might encounter in everyday life. Let's start with the smallest network type, Personal Area Network, PAN. A PAN is designed to connect devices within a very limited range, typically around 10 meters. It's commonly used to link personal devices like smartphones, tablets, laptops, smartwatches, or wireless headphones. PANs can be wired, using USB or FireWire connections, or wireless, utilizing technologies like Bluetooth or infrared. For example, when you pair your smartphone with a Bluetooth speaker or sync your fitness tracker to your phone, you're creating a PAN. These networks are ideal for personal use, offering convenience and simplicity without the need for complex setups. Moving up from personal networks, we have local area networks, LANs. A LAN is a network that connects devices within a limited area, such as a home, office, or school. It is typically used to share resources like files, printers, or an internet connection among multiple devices. LANs are faster, more reliable, and easier to manage compared to larger networks, making them ideal for small-scale environments. These networks can be wired, using Ethernet cables, or wireless, relying on technologies like Wi-Fi. For example, when multiple computers in an office share a central server or employees connect to the same Wi-Fi router, they are part of a LAN. Building on the concept of LANs, a wireless local area network, or WLAN, provides the same functionality but without the need for physical cables. Instead, it uses wireless technologies like Wi-Fi to connect devices within a limited area, such as homes, offices, or public spaces like cafes and libraries. WLANs offer greater flexibility and mobility, allowing users to connect laptops, smartphones, and other devices without being tethered to a specific spot. For example, when you connect to your home's Wi-Fi to browse the internet or stream videos, you're using a WLAN. This type of network is ideal for environments where wired connections are impractical or inconvenient. Next, let's look at the Campus Area Network, or CAN. A CAN connects multiple LANs within a specific geographic area, such as a university campus or a business campus. It typically covers a larger area than a single LAN, connecting several buildings or departments while maintaining high-speed communication. CANs are often used to provide centralized access to resources like servers, databases, or internet connections, enabling efficient collaboration across different parts of a campus. While CANs can be wired or wireless, they are usually set up to ensure fast, reliable connections within the defined area. For example, a university might use a CAN to link academic buildings, dormitories, and libraries to share data and resources across the campus. Moving on to a larger scale, let's explore the Metropolitan Area Network, or MAN. A MAN covers a broader geographic area than a LAN or CAN, typically spanning a city or large urban area. It connects multiple buildings, offices, or campuses, providing high-speed data transfer across the area. MANs are commonly used by businesses or municipalities to link various locations for centralized communication and resource sharing. These networks are often built using fiber optics or high-speed wireless connections, ensuring reliable and efficient transmission. For instance, a city might use a MAN to connect government offices, libraries, and public buildings, offering shared services like public Wi-Fi or centralized data access. Now let's look at the Wide Area Network, or WAN. A WAN is a network that spans a large geographical area, often covering cities, countries, or even continents. Unlike LANs and MANs, which are confined to smaller areas, WANs connect multiple LANs or MANs over long distances, allowing for communication and data sharing across vast regions. WANs are typically used by large organizations, service providers, or governments to link branch offices, data centers, or remote users. They rely on leased telecommunication lines, satellite links, or the internet to transmit data, ensuring connectivity between far-flung locations. For example, a multinational company might use a WAN to connect offices in different countries, allowing employees to share resources and communicate seamlessly across the globe. Now let's shift our focus to a more specialized type of network, the Storage Area Network, or SAN. A SAN is a high-speed network designed to connect servers to storage devices, such as disk arrays or tape libraries. Unlike traditional networks, which handle multiple types of data traffic, SANs are dedicated solely to storage operations, providing faster and more reliable access to large volumes of data. These networks are commonly used in enterprise data centers, where performance and scalability are critical for applications like databases, virtualization, and backup systems. By centralizing storage resources, SANs enable efficient data management, improve storage utilization, and ensure that servers can quickly access the data they need for mission-critical tasks. In conclusion, understanding the different types of networks, ranging from personal networks like PANs to vast global infrastructures like WANs, helps us appreciate the complex systems that connect our world. Each network type serves a specific purpose, catering to various needs, from personal convenience to enterprise-scale operations. While we've explored the foundational network types in this video, more advanced and specialized networks like peer-to-peer, IoT networks, POLAN, and EPN will be covered in a future video. If you're curious about virtual private networks or VPNs, be sure to check out our separate video dedicated entirely to them. Recognizing these systems and their applications helps us better understand modern communication and connectivity. This concludes our exploration of common network types. If you enjoyed it, consider subscribing to our channel and liking the video. Feel free to also check out our other videos on related topics. Thank you for watching.